Okay, so today we are going to do polynomial graphs. So you're going to need to get your foldable, and I have placed a few things on your desk. The outside of the flap that says polynomial, we are going to write this right here. Now, this is a lot of terms. Typically, a polynomial doesn't have as many terms as this, but this is like the standard form of that polynomial. So just take a few minutes. If you need to pause it, go ahead and do that and write down this as your standard form. So polynomials have a lot of different terms, as you can tell. Now remember, terms are what is separated by plus or minus signs. Like this right here, that is one term. What's in green is a second term. Then on, so forth, as many terms as you can possibly think of. That's what a polynomial is. So the very first term that has the highest exponent, so this is going to have the highest exponent, is called the leading coefficient. Leading coefficient. So the highest exponent has n, as you can tell from this term, there is n. And that a sub n right there, that's just a number, okay? That's a leading coefficient. That's why there's a little squiggly here. Any number that's in front is a coefficient. So that a sub n minus 1, that's a coefficient. A sub 3, that's a coefficient. On and so forth, all the way until you get a sub 0. Okay, this is just a plain number. It's a constant. Plain number. So if I want to give you an example of a polynomial, it could look something like this. Y equals 3x to the third plus 4x squared plus 3. Okay, that's an example of a polynomial. We've used polynomials before. Just remember the highest exponent, that is a 3. In this case, your coefficient, or the leading coefficient, that's why we put LC for leading coefficient, is that number in front, that 3. Okay? So that's all what this right here means. I know it looks really confusing, but that's just because there's so many terms. Okay? It can be an infinite amount of terms if you wanted to. Typically, the majority of the time, polynomials for us is just going to have like 4 or 5 terms maximum. So you're definitely not going to have as many as this. All right, so inside your foldable, on the left side, yesterday we sketched each function, so that's what you're going to do here. So to take a minute or so, if you need to pause the video, that's okay. Go ahead and pause it and sketch this. Now, yesterday, all we've done is we went to Desmos, and I wanted you to tell me what were the x-intercepts and the vertices, or vertex. Now, for polynomials, you may have more than one vertex, like if you see here. A vertex, if you remember, is just a max or a min. So in this example, I can see that I have a minimum here and then a maximum somewhere up here. So both of these is like how we yesterday identified vertex. Now, yesterday we also identified the x-intercepts, which were also called roots or solutions. And those are wherever the graph hit the x-axis. So if I look at this picture, this is my x-axis, as you can tell, here's my x, and it hits it here and also here. So both of these help me find my x-intercepts. Okay, and remember, Desmos, all you have to do is like click these points and the order pair pops up. Those are your answers. On the right-hand side, we listed some characteristics. Now, for polynomials, you have more characteristics than what we did for quadratic or absolute value. So that's why we're only doing polynomials today. And I know it's going to be kind of a lot, but some of this you should have seen before. All right, so some characteristics. Number one, graphs can have any maximum and minimum points. Like you just saw before, you see how this one had more than one? That's okay. For polynomials, you can have a lot too. So just make sure that anytime you have a part of the graph that looks like this is going to be what's called a maximum. Or a part of the graph that looks something like this is a minimum. All right, so just be able to click the points, tell me what they are. Okay, another part of the graph is multiplicity. Now, multiplicity can also happen to quadratics, but it's mostly used for polynomials. I'm going to make this bigger, and remember, you can pause this at any time so you can write it down, whatever you need. So I'm going to make this bigger. So, given a graph, identify the multiplicity. So, if the graph crosses the x-axis and appears like a linear line, it has a single zero. Okay, so just one answer. Just one. If the graph touches the x-axis, it has a zero with an even multiplicity. So that means it has a multiplicity of an even number, like 2 or 4 or 6. And if the graph crosses the x-axis at a 0, it is a 0 with an odd multiplicity. So to kind of summarize this, if it touches the x-axis, that's going to have a multiplicity of an even number. And if it crosses the x-axis, that's going to have a multiplicity of an odd number. So evens like numbers like 2, 4, 6. Odd is 1, 3, 5, on so forth. Okay? And we're going to do some examples of these in a second. So I'm going to make this small now. Okay. The next vocabulary word that should be kind of new is the end behavior. Now, end behavior is what's happening at the ends of the graph. Okay. So, like if I make this larger, if you know the degree, which is talking about the multiplicity, if it's an even degree, then A, your first term is positive. They're either both going to go up like this. So that's just the ends. Okay, what happens in the middle doesn't really matter. It can be whatever in the middle. Does not matter. The ends are going to both go up. And if the ends go up, that means that we're going to write infinity. All right, so if this is like a foreign concept to you, it may take just a little bit to do an example, but you're just looking at the ends of the graph. All right, so you're going to be given a graph, you're going to look at the ends. If they're both going up, you're going to write the infinity. If one's going to go down and the other one goes up, then the end behavior is going to look a little bit different, right? Because one's going the opposite directions. So, as x is getting smaller, right, it's going to the left, x is getting smaller. In this case, y values are going to get smaller. So we put negative infinity. So whenever something's getting smaller, we're going to put negative infinity. And as x is getting bigger, what's happening to y? In this case, y is going up, and it does not stop. So that's going to get bigger, so then we put infinity. Okay? So, if you have an even degree with a positive leading coefficient, then that means that this is going to be your end behavior. So if I want to give you an example of this, an example of a polynomial that will have this is maybe 3x squared. See, 3 is a positive number, and that 2, which is your degree, that's the highest exponent, that's an even number, so this is what the end behavior is going to look like. Okay? For your next one, if it's an odd degree, think about the exponent being an odd number. So like maybe x to the 5th. But the leading coefficient is still positive, so I'm going to keep it as 3. Because that 5 is odd, this is what your end behavior is going to be. Alright? As x is getting smaller, y is going to get smaller. And as x is getting bigger, y is going to get bigger. Right? So, those are positive leading coefficients. Now, if the leading coefficient is negative, something else is going to happen. So that's where I have the second part. Remember, this is just talking about the ends of the graphs. So, if you have a negative leading coefficient and the degree is still an even number, like maybe negative 3x to the 4th, something like that. The only thing that changes is this is now a negative. Instead of both of the ends going up, they're going to both go down. And if they both go down, then we put negative infinity. Okay? For the next graph, if you have a negative leading coefficient, so I'm going to put as a negative 3, and your degree is odd, so I'm going to keep it as to the 5th power. As x is getting smaller, y is getting bigger, so it's opposite. If y is getting bigger, we put infinity. In this case, as x is getting bigger, y is getting smaller, so then we put negative infinity. So it's opposite of what we just said. And it all depends on that coefficient, that number in front of your term with the highest exponent. So if you did not do this in Math 2, it's going to take some time to kind of get used to, and we'll work on that. So especially in the examples. Just be sure that when we do this in class, you're asking like where did it come from. But just look at the charts. Okay, it would kind of tell you which end behavior to use. So it should be pretty easy. If I give you the graph, then you can tell me which end behavior should it be. Okay. The last two is talking about domain and range, which we mentioned that a little bit yesterday. The domain's all the x values. Now, for a polynomial, it's always going to be all real numbers, which means that x could be any value. Does not have to be any certain value, any value. Now, just like yesterday, range is going to change depending on the graphs. So we'll talk about that again as well. Okay? So let's do an example real quick. I'm going to pick the first example here, and I'm going to type it into Desmos, and I'm going to find the zeros, the max, and min. So kind of like what we did yesterday. These are just regular polynomials, so this should be just like we did yesterday. So I'm going to go to Desmos.com. I'm going to hit the Start Graphing. And then where it has this little tab, I'm going to type in, remember f of x, I could type that in. It's not going to mess up my graph. Say negative x to the 3rd plus 2x squared minus 4. Now, this is what my graph looks like, and you can zoom in if you need to. Oh. So whatever you need to. But here's my graph. If I want to find the zeros, that's where they're going to hit my x-axis. So I'm going to go to where I see my x-axis, which is right here. I'm going to click the point. That's my 0. So my 0 is negative 1.13, comma 0. I'm going to write this down. So 0, negative 1.130. Okay, and that's the only time it touched the x-axis. So that's my only 0. Now, for max or min, I'm going to write this down too. They're just going to be points. So in this case, I'm going to click this to kind of get rid of it because I don't want it. Maximum looks like a U, like an upside down U, like a frown. So this right here is a maximum. You can see kind of how it looks like a frown. So that's 1.3 and negative 2.8. 1.3, negative 2.8. Right, and then I'm done. Okay, so this is your maximum. Minimum is going to look like this. You see how it kind of looks like a smile? That's 0, negative 4. Right, and then I'm done. Okay, so real easy, just like we did the other day. Okay, I'll do one more. Let me do number 4. Before I do that, I'm going to take a picture of this so you can have it for later. And we're not going to use the graphs that I give you up here, so I'm going to just replace it. Okay, so let's do number 4. That's negative x to the 4th plus x squared. So I'm going to erase this. You can type in f of x equals negative x to the 4th. Is it plus x squared? Yeah, plus x squared. Okay, so this graph looks a little strange. You can zoom in if you want to with the little plus button. You can drag it, whatever you need. Okay, so zeros. Where I see it touches the x-axis, I see here. I just click it and it's there. I see here and I see here. The good thing about Desmos is it already kind of outlines the main points that you need. So you have 3 zeros. So negative 1, 0, and 1. So for your zeros, negative 1, 0, and 1. Okay. Your maximum, once again, looks like this. So that's 1, 2. So that's negative 0.7, 0.25. And then it's going to be a positive 0.7, 0.25. Okay, and your last one's a minimum. Now remember, your minimum looks like a smile. Now, I have all the points here, which means my minimum can also be a 0. So if I look here, there is like a smile going on. So my minimum's also 0, 0. So that can happen. Just know that a maximum looks like a frown, minimum looks like a smile. Okay, so now you should be able to pause the video and do the second and the third one to make sure that you got it. All right, so use Desmos. You're just clicking the buttons. It should be pretty simple. Okay, I'm going to take a picture of this so we can have it. And then we're going to move on to some of the other properties that we've talked about. So, remember, we talked about multiplicity and end behavior. So that's what we're going to look at next. The first one that we're going to look at is end behavior. And I just posted these pictures again so that we can see them if we need to. Remember, these are going to help you. They're like little charts. Now, before you can tell me the end behavior, you're going to need to use a graph. So it tells you here, describe the long-run behavior or end behavior of this function. Okay, so I'm going to type in this equation. Now with Desmos, and you may see this on your final exam, it does not have x in this equation. When I go to type it in, I need it to be x. So anytime that you see a p, I'm going to type it in x. So that's going to be like f of x equals, that'll be 3 parentheses x plus 2 squared. Okay. Now I'm not finished yet. I still have another parenthesis, x minus 3 to the third power, parenthesis x minus 2 to the third power. So just type it in just like you see it. Now you're lucky having Desmos, because if not, it would have made it really confusing. And this is your function. Looks really interesting, right? Now, because you're caring about the end behavior, you only really care about what's happening at the ends of the graph. So if you look to the left, you see that this is going to go up. And if you look to the right, you see that this is going to go up, right? So if I look at this chart, which one both goes up? So when you look at the left, it goes up. When you look at the right, it goes up. Well, it has to be this one, right? You see the left goes up, right goes up. So your end behavior is given to you as x is approaching infinity. So in this case, they use p, but still the same thing. As x approaches infinity, f of x, or f of p, approaches, and it's going to be an infinity. But as x approaches negative infinity, f of x, or f of p, approaches, and you look down here, and it's also infinity. The reason why it's both infinity is because the graph is going up. In both directions. Okay, so all you're going to do is you are going to graph whatever is given to you and then match up with what's happening at the ends with one of these charts. Now, once you do that, the end behavior should be right there written for you. You just copy it down. Sometimes they give you different variables. That's okay. Just treat it like x. Okay? You can't help what variables they give you. Now make sure you have these pictures drawn somewhere on your foldable. Okay? If it can be inside your flap, that's great. If not, then you should have room on the back to do this. So draw your pictures. Make sure you label them like it is, because that's how you can figure out what's going on. And write down your end behavior. Alright, so make sure you pause the video and do that. That right there will help you on the end behavior problems. Okay, so the last one, before I'll do a few on your worksheet to kind of help you out, is talking about multiplicity. So going back up here, multiplicity is where if it touches the x-axis, it's going to be an even number. If it crosses, it's going to be an odd number. So what you're going to do is you're going to look at every single point that touches the x-axis. So I see one here, I see one here, and I see one here. Remember, what touches the x-axis are called roots, zeros, or solutions. So, given that the degree is 3, that means the highest exponent is 3. Complete the table of values for either the x value of a 0, which we've already identified, or the multiplicity. So the first one, the root, is a -5. We already have that. The second one should be a 0. So here's that one. And the last one should be a 5. Now, if it crosses the x-axis, then it has a multiplicity of an odd number, like 1 or 3. In this case, because they told me that my degree is 3, and I have 3 places where it hits the x-axis, then that means that it's going to have a multiplicity of 1. Okay, so odd 1. So if I look here, I'm going to follow the graph. It's following, following, following. It crosses, right? So my multiplicity is going to be a 1. We do the same thing for each one. So for 0, I see it's going here, it's going through, crossing it, and it keeps going down, right? So that's another multiplicity of 1. All right. Then last one, crosses, it's going to keep going, crosses. That means that multiplicity is going to be a 1. Okay? So multiplicity, you just see the graph. If it crosses, it's a 1. If it just touches, it's going to be a 2. So just to kind of show you what that's going to look like, if I give you something that looks like this. Like that. And let me give you these points. Let me say that this is -3. This over here is +3. Okay? And know those are my zeros like we did before. If I follow the graph, I see it's going to touch and then go right back up, right? It does not fully cross the x-axis. So this one is going to be a multiplicity of 2. Okay? And then for 3, same thing. It's going to go through, cross it, keep going down. That's going to be a multiplicity of 1. Okay, so this is what a touch looks like. It touches and goes back up or goes back down. This one, it crosses and keeps going in the same direction. Right. Now, on the worksheet, you have a couple of examples to do. I'm going to do the first one in each to kind of help you. Or I'm going to pick one. I should probably do that. Okay, so here I'm going to give you a function. You are going to tell me the degree, which that's going to be the number of exponents you have, and the end behavior. So for end behavior, remember, look at that little chart I gave you. That should be very, very easy. Now, to figure out the degree, I just need to count how many times it hits the x-axis. But remember, if it touches, that's going to automatically count as a 2. Okay? If it crosses, that's going to count as a 1. So, when I look at the first graph, I see that this is my zeros. And I see that they just cross it. So those are going to count as 1 and 1. And 1 plus 1 is 2. So that's my degree. And if I look at the end behavior, I see that they're both going down, right? So if they're both going down, I'm going to look at this graph right here. And there's my end behavior. So they both should have a negative infinity. So go here. I should have negative infinity and negative infinity. Right? So let me do another degree for you, being that that's kind of new. Let's look at number 4. Figure out how many times it crosses the x-axis. Like there's 1 here, 1 here, 1 here. If it touches, you count it as 2. If it crosses, it's just 1. So here, that just touches, so that counts as 2. For your second one, it goes through, so that counts as 1. And for your last one, it just touches, that counts as 2. And then add them up. 2 plus 1 plus 2, that is a total of 5. Okay? And then see which graph matches up with your arrows, and then you plug that here. Okay? All right. Now, this part should look very familiar to you because we've done these before. This is where you have to work backwards to get your polynomial. So I give you the answer, you're going to give me the polynomial. The only difference is now you're going to see these words like in parentheses, MO2, 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 MO2. What that means is multiplicity of 2. So MO2 means multiplicity. In this case, we're going to count multiplicity of 2. So if I want to do number 8, my zeros are -6 and 3, but that 3 is there twice. So I'm going to write this out as x equals -6, x equals 3, and if I have it twice, I'm going to write it again, x equals 3. Now, I can't write them like this. I have to let the right-hand side be 0 because that's how I work backwards. So I'm going to add 6 to both sides. Those cross out. And that gives me x plus 6 equals 0. Do that for each one. So if I do it for this one, that's going to be by subtracting 3. So I get x minus 3 equals 0. And I should get the same thing here, x minus 3 equals 0. Now, to write my polynomial, I don't want the equals 0 3 times. So I'm just going to write all of the factors. I'm going to say p of x, that's my polynomial, equals x plus 6, x minus 3, and x minus 3. And then I'm finished. Okay, so this should be really, really easy. Now, if you have a fraction, like let's say that 3/4, so x equals 3/4. Remember, take care of the denominator first, so I'm going to multiply by the denominator. And then get 0 on the right-hand side, so I'm going to subtract 3. Okay. And do the rest like normal, put them all together, there's your answer. So, that's your second part. That one should look very, very familiar. Your last part. You do not have to fill out the graphs. You already have Desmos. And I want you to ignore this extrema, these factors, ignore all of this. Okay, all you are going to do is find the zeros and the end behavior, which we've already talked about before. So zeros are where they hit the x-axis. End behavior, just look at the graph and use the charts. Should be very, very easy. Your job is to finish this and turn it into the box. Okay, use Desmos to help you. If you do not understand how to find something, ask one of your neighbors. I'm sure that maybe they picked up something that you did not. Help each other out, that's fine. Make sure that you have this finished. It should not take you too long once you know what you're doing. If you need to go back and to get the rest of the notes, please do so. Your foldable should also be turned into the box, and you should have all of polynomial finished. So when we go to class tomorrow, we're going to do the last one together. Okay? Have a good day, and I'll see you tomorrow.